Hi, everyone. Welcome to the Apache Iceberg Meetup Europe in Budapest. I'm glad that we've got so many people here inside of that room. Was quite interesting when I started to organize that meetup. I reached out to Gabor and we had a conversation. Is it a good place to start Iceberg Meetup? And it looks like it is a very, very good place, and it was a very good decision. So thank you for you to be here. And what I want to start is as well saying thank you to Cloudera to give us this venue, and saying thank you for Microsoft for all that snacks. And therefore, guys, if it's okay for you, just a small applause to our hosting people and companies. Very quick introduction about Apache Iceberg Meetup. So many of you probably know what is Iceberg, and many of you is trying just to get all that information. And I was here speaking to a couple of you like, okay, guys, if you need information about Iceberg, you need to fly over to Bay Area. And that's why we started to create the community here in Europe, and we just going like country by country. And you can see actually on the colors here, on the green one, it's already where we had the meetup. And there are some yellow countries. So if you planning to travel and just want to go to your boss, you can say like, hey, boss, I want to have here a meetup at Iceberg as a speaker, as like attendee. I know there are some in North where we have Christmas. You can meet Santa Claus. Use your chance. And not going to take the whole time here. So we have very great speakers. And I will just pass over to Gabor directly to start with his talk about REST catalog basics and what you were to ask. Gabor?
Thank you very much. I already broke something, sorry. Okay, is it not advancing? Okay. Do you hear me? Okay, do you hear me now? Thank you. Okay, so I'd like to talk a little bit about catalogs in general in the Iceberg ecosystem. I would like to start from the very, very basics, and let's see how far we get in these 20 minutes. Hopefully at the end of the presentation, you will have something to take away with you. So before jumping into the topic, let me share a couple of sentences about myself. This is a Copilot picture. I'm Gabor Kasab, and I work as a software engineer for Microsoft. And well, I belong to a group of researchers where the topic is anything related to big data, like graph databases, GPUs, whatever. I mostly concentrate my efforts on table formats, and I have some exposure to file formats as well. And I also concentrate my efforts into open source contributions. So myself is a contributor to Apache Iceberg, but I'm also a PMC member in Apache Impala. And a fun fact about me is that before joining Microsoft, I spent 8 years in this very same office working for Cloudera. So let's move on to our topic here. In case you just search for Apache Iceberg, this is what you found. This is an open table format for analytic data sets. The other day, I heard a different description about this. So one of my colleagues said that, well, in case you ask me, Iceberg is a specification that tells you how to organize your metadata on top of your data. So I think this is also true. It depends on which angle you want to tackle this question. And in fact, there is a specification, you can open it, and there are a lot of things that you find there, like time travel, optimistic concurrency, and everything that is related here. And there is since this is a specification, there are reference implementations. One of the ones that most follows the specification is the Java implementation, but there are other languages as well. But if you come from another angle, we can say that Iceberg is an ecosystem. So it can be a specification, it can be implementations. There is a concept of catalogs, but you can also have a lot of applications that are responsible for, let's say, keeping your tables healthy, like table maintenance. And it's not just that, it's, as the Apache way says, community over code. So we talk about code, but also the community is very important, and Iceberg has a very vibrant community. From this ecosystem, I would like to focus on that top shape, the catalog that sits on top of your data. So let's see what is the role of a catalog within this Iceberg ecosystem. So in case, this is a picture that you find in the Iceberg spec, almost at the top. So this gives you an impression that the Iceberg catalog's main responsibility is to hold a pointer to the current metadata file of a table. And that is true, but is there anything else besides this? I mean, it can't be just that, right? So if you take a closer look, there are other responsibilities. One equally important is the giving you a way to atomically commit into your table. So when you have your metadata pointer to the current file, you have to have a way to flip it to the next one when you, let's say, insert rows into the table and you have a new metadata file. And that has to be done atomically. This is a responsibility of a catalog. But other than that, what you can expect from such a catalog is to give you a way to read metadata, Iceberg table metadata, write, delete, all kind of CRUD operations, but on the metadata itself and not expected to do the same on the data through the catalog. They could give you fancy features like help for access control and then server-side planning and such. There are many implementations of such a catalog. In case you see the bare minimum expected from the catalog, you just go to the Java code, there is an interface called catalog. So there is a load table, create table, register table. Those are the bare minimum. But then the different implementations add a lot on top of this. So such implementations can be the Hadoop catalog, Hive catalog, backed by HDFS, Hive Metastore respectively. And there is a long list of catalog implementations. REST catalog is one of them. So let's drill down into what is actually REST catalog and coming from the Iceberg library's perspective. So what the Iceberg library has on catalogs is that there is a specification for the REST catalog. So that is part of the Iceberg library. That's a long one. So you go into the specification and what you will find is that in case you have a server that behaves like an Iceberg REST catalog, then these are the requirements that you have to meet. These are the endpoints that can be provided, REST endpoints. And these are the incoming messages and the outgoing messages, including all the headers, the parameters, and such. So basically, from the Iceberg library's perspective, the REST catalog is a specification. But is there anything else? And yes, there is. There is a reference implementation of this Iceberg REST spec. If you take a look at the reference implementation, let's say the reference IRC, so IRC stands for Iceberg REST Catalog, that's very, very basic. So that is for demonstrational purposes. It contains the very basic functionality like creating a table for you. You can set it up to run it as an HTTP server and then use it for your tests, but not recommended to use it in production. So where should you go to have a REST catalog to use it in production? And you have to go to vendors. So there might be proprietary implementations, and there can be open source implementations of the Iceberg REST catalog like Polaris or Lakekeeper or Gravitino. So just to demonstrate how the message flow goes through the client of the REST catalog and the REST catalog server itself, let me walk you through a very basic use case. So the use case is that you have a query engine. You just start it now. The query engine connects to your REST catalog and then do very basic stuff like loading a table and then inserting some new rows to this table. This can be easily done through a test suite called test REST catalog, because how it works is that it fires up a reference REST catalog as an HTTP server for you. You can easily, so with that one line of code, you can connect to this REST catalog and then you can invoke a lot of functionality on this REST catalog. So if you know where to put your breakpoints, you can easily catch the messages transferred between the client and the REST catalog itself. So the whole sequence of messages start with initializing your client-side object for the REST catalog. So how it starts is that the client asks for tokens from the REST catalog. These are needed. The client says that this is me, these are my secrets, so how can I communicate with you from now on? And then the server says that, okay, I know you, these are the access tokens that you have to use in order for me to serve you. So later on, during this initialization phase, there is another query going to the REST catalog called get config. And please note that there are some headers, and those headers are coming from the previous message. Those are the access tokens. So this is what the client does from this point on, that it enhances all the messages with these access tokens. So basically, this get config is like asking the server to tell more about itself. So then the server says that, okay, here am I. Yeah, these are the parameters that you have to set on the client side, and these are the endpoints that I support. Later, the endpoint is important because not all the REST server implementations have the same capabilities. So let's say that the view support on top of the table support was implemented later, and not all REST catalog servers support that. So these will omit the view endpoint from the supported endpoints, and we'll let the client know, because then the client won't be just firing these unnecessary queries to the REST server. Also, there are some properties that have to be applied on the client side, and here the order matters. So there are defaults. So those are nice defaults that the client can override. But there are overrides that are basically overrides on top of the overrides. So those are the must required by the server. So when this is done, the client can, so this is a load table response. This is a very simple one. If you take a look at this REST endpoint, it's varied by the get method. It contains the database name and the table name, and actually has no body, so nothing else is required here. Optionally, you can have some parameters to ask whether to have all the snapshots or just a subset of the snapshots, the ones that are referenced. So in turn, the REST catalog sends you a load table response with a 200 status code. It contains metadata location, the table metadata. It has, well, basically everything about the table, like the schema, the partition spec, the list of snapshots, the parameters of the table, everything you can imagine. And then there are two additional fields, the config and the storage credentials. So the config is used on the client side when it communicates with the REST server. So it says that whenever you communicate with me with regards to this table, please use this config. On the other hand, the storage credentials are so-called vended credentials. So let's say that your user doesn't have all the access to like an object store. But then the REST catalog can give access to this user in a sense that it gives some credentials, temporary ones, and say that, okay, in case you use these and you want to access the data files belonging to this table, please use these credentials when you go to the object store, and it will let you in for a time, and then it expires, and then you have to get them again. But hold on. So there is a perception that the REST catalog only gives you, or the catalogs in general in Iceberg only give you the metadata location, right? And then on the client side, you have to use this metadata location, go to storage, read up all the metadata files, construct them into the internal representation of the metadata, and then move on. But this is not the case with the REST catalog, because here, the metadata is in fact read and put together on the server side, put it into a REST message and send back to the client so that the client doesn't have to do it itself. This is very different compared to, let's say, the Hive catalog and the Hadoop catalog, because they simply provide you a location, and then it's a client's responsibility to go to the storage and read the metadata. So this is one major difference to note. And then once you loaded the table, you can insert some new rows into the table. These go through the append files API of the table. You can provide a list of files here that you want to append to the table. And in case you are wondering how many messages this takes, well, you would say one, right? So you just tell the catalog that this is what I would like to add. And in fact, it's not the case. First, it starts with a regular load table request. So the reason is that whenever on the client side you are creating a new snapshot, you want to put it on the latest metadata. So all the changes you want to apply it on the latest metadata. So first you get the latest one. This is why you have a load table request at the beginning. Then this is the update table. where you want to ask the REST catalog to update your table. This contains two important fields, the requirements and the updates. So the update is what it seems. So it contains a list of updates that you want to make the REST catalog to perform on your table. Like these are the new files, this is the new snapshot, these are the new configs, these are the schemas I deleted. So it's a list of updates that the catalog server applies. On the other hand, the requirements is you can send some checks to the REST catalog that what you want the REST catalog to perform. So for instance, what you can do here is that when you apply your changes on the client side, you know what the latest snapshot was. And you can tell the catalog that this was the latest snapshot. And when you apply the changes, I want you to make sure that this is still the latest snapshot and no one concurrently changed the table. So these are kind of requirements that you can send to the server side for the REST catalog to perform. When it succeeds, it sends back a message that is very, very similar to the load table response. It has the metadata location and the metadata. It doesn't have a config or storage credentials field. So this is something that you only get through a load table. And when I was making this experiment, I was very surprised that there is another round of load table requests on top of this because of answering some listeners and metrics reporters about the table. But this is under investigation whether this is needed or not. So the topic that I would like to drill more into is client-side caching because, well, it would make sense to cache your table metadata on the client side, right? Because in case you have a very, very basic query engine that runs to the REST catalog every time you run a query, well, it's a lot of queries, right? In case you have a very, very wide table with a very, very huge metadata, it can be tens of megabytes, hundreds of megabytes, you don't want to query it every time. So you want to have a way to cache them. This is where caching catalog comes into the picture. This is provided by the Iceberg library. So how it behaves is that on the client side, when you construct your catalog instance, so let's say it's a REST catalog, you can wrap it into a caching catalog. So every time when you want to load a table, this wrapper first goes to the cache and it checks whether the table is there or not. If it's there, it's fine. I will answer the query from the cache. If it's not, it goes to the underlying wrap catalog and loads the table through them and then puts it into the cache. This is great for some use cases, and this can have some shortcomings in others. So one shortcoming here could be that how this cache is configured. You can configure an interval, how long a table should live within the cache. It's configured with an expire after access. So let's imagine where this can break. You have a use case that is frequently querying one single table. And then in case the query interval is shorter than the expiration interval, it will just simply keep your table within the cache alive. Even if the table has changed long ago, it won't be refreshed within the cache. So there should be a way to somehow get around this and have a cache that takes freshness also into account. And by this, what I mean is that it only reloads the table if it's changed. And if it's changed, it reloads it. You can make sure that it reloads it. So there had been a long conversation about this on the mailing list, on the Iceberg's mailing list. And the first proposal was that why don't we have something like is latest? Because then in case it returns false, I can just do the regular load table on the client side. But it has two shortcomings or drawbacks. One is that it's two round trips. You have to check the freshness of the table, and then you have to load your table. And also it would require quite invasive change within the REST catalog, the REST endpoint, and you have to extend the catalog API as well. So the second thought was, why don't we have one single function, something like load table if changed? And then you only have one single round trip if you manage to tweak the REST spec in a way that you can reuse the existing load table API, just add a couple of new parameters, and then it can perform you this. There is one shortcoming for this is that it requires a catalog API change. So the problem with this is that in case you have a query engine like Impala, Spark, whatever, it calls the load table API. So it's a change in every query engine so that you can use this more optimized way of reloading tables. And in fact, the third approach was the one that was approved by by the community. So the idea here was to keep the catalog API intact. So let's leave the load table as it is. Don't introduce new ones, and hide everything underneath this load table call. And what we could, so the catch here is that what we could leverage is that there is such a functionality called HTTP caching. It provides you headers, result codes, status codes, whatever. So we could reuse them to communicate with the REST catalog. So one building block is something called eTag. That's a header that a server can send you with a response. And so basically, eTag is something that describes an actual state of a resource. So now a resource can be a table. So in case the table changes, the eTag changes. So this is something that describes that what state of table you hold of. The other building block is the if non-match header. So that is something that is sent by the client to the server. And this is how the client tells the server that this is the state that I know of the resource, the table in this case. And the third building block is the 304 not modified status code that is expected from the server telling the client that whatever you showed me, the last state of this resource, it's up to date. So you are fine with that. There is one more thing that we had to do on the client side is to have some kind of a table cache. Because let's imagine that you receive a 304 telling that the table you have is fine. You need to have some kind of a cache to pull the table from the cache and give it to your caller, like as a result or return value. So let me walk you through the message sequence. I think it will tell more than just a pure text. So please notice the table cache that is empty. And this is the very first load table request from the server from the client to the server. So this is as usual. But then the server answers with a somewhat usual response, but there is one change is that it includes the eTag header. So say it says that, well, this is the metadata, and we can describe the state of the metadata with this eTag. And then we can save this whole thing into the cache. So there is a table object, and there is the eTag stored in the cache. So when we have the next load table response, we can get the eTag from the cache. Tell the server with the load table request through this if non-match header that this is the state I know. And then the server can say that, okay, you are fine. Just pull the result from the cache and return it back to the users. So what happens if there is another client that changes your table in the REST catalog? Then, well, your cache got stale, right? So with the next load table, you still include the very same eTag that you had in the cache, but it won't match the one on the server side. So the server will decide to send you the new metadata with a new eTag, a new value, and you have to update your cache, put your new table object and the new eTag into the cache. So this is something we call freshness-aware loading. And just for the record, I'm sure you will get the presentation slides. So there is the design doc linked here. There are a couple of pull requests. So the REST specification side is done. The server side on the reference implementation changes are done. At the client side, pull request is still open under review. Feel free to take a look at it. That's all from myself, and I'm not sure how much time we have for questions. One?
Thank you very much.
Thank you.
And let's just use a chance to ask one or two questions. Do we have like any questions to Gabor about his presentation? Yeah?
Attila?
So my question is around actually the caching. So these type of cache that you mentioned on the server side, is it something that is possible to configure for Redis, or it is something that is just a one instance in-memory cache on the server?
Well, this is between the application that runs the Iceberg library and the Iceberg REST catalog.
But okay, but if in that case that your REST catalog is in HA, so every single REST catalog has an own distributed cache, or it is a single point?
It's not the REST catalog that has the cache. It's your query engine like Impala, Spark has.
Okay, it's on the client side, so in this case. Okay.
So the cache is on the client side.
On the client side, okay.
Yeah. No tricky questions.
Okay. Well, I would say we can just go to the next speaker.
Okay. was meant to be 2 more questions. Can we have
do we have a
we
question?
can have now, or we can have during the break.
Okay. Then thank you very much, Gabor. Thank you very much for your presentation. And we have a next speaker. It's Attila Pap, who is going to talk about the change data capture, how to master that. It's going to be very interesting. So it takes a couple of minutes. Maybe just guys, just to understand how familiar are you with Iceberg? And just asking you, raise your hand who is actually played with Iceberg already. Oh, not that many. So, and who? Yes. So one of the speakers played with Iceberg. That's a good stuff. So how many of you do have Iceberg in production? Very experienced users here. Okay, cool. How many of you do plan to use Iceberg in the future? Ah, very good, very good. So it looks like we do have some experience with Iceberg, and I hope that the main thing is just to learn more about Iceberg, and we are online. Perfect. Then I will pass the mic to you. And Attila, stage is yours.
Thank you, Victor.
Use your time.
Good evening, everybody. Hello, I'm Attila Pap. I work at Adesso for almost 5 years now. And in the last few years, I've been working with a client who is a car manufacturer from the Stuttgart area. Its name starts with P, but I can't tell you more. I've been working on an interesting project, which started out as a data lake, and then we started migrating towards a data mesh concept. We are still in the process of doing so, but one topic which is common through the data lake as well as the data mesh is Iceberg. So we are heavy AWS users, and I want to tell you a little story on how we solved the change data capture when we migrated from plain Parquet to Iceberg on AWS. So just a quick recap, because some of you might not have heard of CDC. It's basically a pattern that helps you capture only the changes that have been done to an upstream data set, which allows you to achieve higher levels of efficiency. You achieve this by not reading the complete data set over and over again, only that changes the delta, so to say. There are 2 types of CDC approaches. I would say batch CDC is what we mostly have. We have some streaming tables, of course, but for that we use different technologies like Firehose and Spark streaming. But many of the use cases batch side could very well benefit from CDC. So today I will be mostly focusing on the batch side of the story. Of course, if you increase the loading frequency in a batch setup, you are getting closer to a continuous implementation. Batch is what we had, and that's what I want to showcase to you. This is a very simple high-level architecture diagram of how a simple pipeline on AWS could look like. This is some of the services we also use. So step functions for scheduling, the data pipelines, orchestrations, and whatsoever. For some of the ingestions, especially for REST APIs, we use Lambda and some other services. We store the data on S3. We follow the medallion architecture, but this will be changed soon. And we used AWS Glue jobs for processing. For those who don't work with AWS, it's basically managed serverless Spark, at least some parts of it. For access control, we use Lakeformation and Athena for querying. We used to have something called job bookmarks when we were on Glue with plain Parquet. which is quite cool because Glue gives us some tools to persist the files that have been read or that have been processed by a given run. It does it based on the last modified timestamp. So on subsequent runs, only those files will be read that have been modified or added since the last run. This is quite simple, yet quite useful in many cases. We relied on this quite heavily. It's I mean, what can I say? It's a nice, boring, but reliable solution. However, when we migrated to Iceberg, this wasn't available anymore. And the main reason for that is, I would say, Iceberg is rather a table format instead of parking it just being a file format. Anyways, we wanted to switch because it added some critical capabilities, most importantly, the time travel capability and ACID transactions. However, since Glue bookmarks are file-oriented and not table-oriented, we didn't have this feature available. So yeah, basically, job bookmarks with Iceberg are not available. So what can we do? What we wanted to achieve with our own from our own bookmarks is the following behavior. So on the first run, whenever a table is being read for the first time, an upstream table I'm talking about, we wanna do the full read, process everything, and then on subsequent runs, we only wanna read the changes since the last bookmark position, and we would like to also have some kind of short circuiting implemented, namely, if there have been no changes, the job just finishes. There was one constraint which I will talk about later. So how can we achieve this with the native Iceberg toolset? For one, there's this feature called the snapshots. We can store, let's say, the snapshot ID that we processed, or we can also do this based on the committed at timestamp. We can make use of the metadata tables, for example, querying the snapshots. And here I get to the main point of the presentation, is using the native Iceberg toolset called create change log view, which is a procedure. When you do so, you can address it with the following logic. And this is what we created quite quickly. Just look up the bookmarks per data source. If there is no bookmark, we do a full load. If we see the same snapshot in the bookmark as the latest snapshot in the table, we skip the job, we skip processing, or we return an empty data frame. But if you see different snapshots, you try to get the changes with the procedure. We call the create change log view, read the data, do our thing, and then update the bookmark. Quite simple, right? How we store the snapshots currently, it's on S3. Just a simple enough, stupid enough solution. We save the committed snapshots per data source, and yeah, we use Boto within Spark for that. We developed some kind of a toolkit for this behavior, which I would say is in progress for open sourcing. Is something like this. The interface looks something like this. You give it a database table, and then you try to get the change the data. It's just a little wrapper around the Iceberg utils. What happens inside the function is we get the committed snapshot from the storage, then we get the net changes, and then return the results as well as the latest snapshot ID. Once again, if there's no bookmark, we do a full read. If everything is up to date, we return an empty data frame. And if there have been changes, we give the data. How does it look like under the hood? It calls correct me if I'm wrong, but it's a procedure in the catalog or something like that. you give it what you want to have, and you can supply the start snapshot ID as well as the end snapshot ID. We also use the calculation of net changes, which means that the changes in between the two snapshots will be calculated to show the final state. And once you create this view, you can just read from it with regular Spark. We decided to store the snapshot progress per data source, but of course, you can do your own implementation. Like I mentioned, we just went with simple file storage, but there can be other solutions. And now I want to do a demo, which will be a bit interesting with one hand, but I promise I will try. No, that's okay. I'm mostly clicking around. So I created a little notebook, and I will spin up the New York taxi dataset. Some of you might have heard of it, and if I pray to the demo gods, everything will be okay, I hope. So I created this little notebook for showcasing the functionality live. So basically, I make sure the DB table is created. I read it and save it in Iceberg. It's I would say the standard demo data set. It has some data about taxi fares in New York City. By the way, Victor, let me know when I have only a few minutes left. Here's the count so that you can see the CDCA behavior later. And snapshots wise, we only have one snapshot, right? We only did one append operation, so nothing fancy. Let's say I want to read the next month. After I read it, I should have one more snapshot, right? And now comes the magic. Actually, let me just, oops. As you can see, there have been two append operations, and let's say this is the job bookmark. This is where the job bookmark is pointing. With the toolkit I mentioned, I would download it from somewhere and create this changelog view. And last but not least, if everything is okay, I get the data. So now you can see only data that have been added since the last snapshot. Yeah, so this is how it works with the native Iceberg toolset. I want to quickly highlight three interesting topics or three interesting columns. These are added to the view. You can see the change type. You can also see some change ordinal, which showcases the order between the records or how they relate. I don't know exactly how it works under the hood, but it basically showcases the order. So what we learned after migrating almost all of our jobs to, I mean, some, let's say the majority to Iceberg, and using bookmarks is retention time is key because we used to expire snapshots quite aggressively. And if you want to reprocess some time back in the future and let's say reset or go back to an earlier bookmark, it can be tricky. So we settled to this 7 or 14 days range. You can drop the metadata columns if needed. Of course, for multiple sources, we commit per source. And like I mentioned, it's a batch use case, so there aren't really any concurrency topics in mind, but this would be still an open point to investigate. And the other thing which I wanted to mention is using Iceberg on AWS these days, especially when you use lake formation for access control, is a little bit challenging because Victor is already laughing. It's a little bit challenging because these functions from the catalog are not available via lake formation. So we have to fall back to regular old IAM roles, which is not the best. I don't quite understand why, because I looked at the Iceberg code and this create changelog view is only doing reading operations. So I don't quite see why they made this, but yeah, maybe there will be some change down the road. So what are some of the takeaways I wanna highlight is you can recreate bookmarks, or you can achieve this bookmarking behavior with the native Iceberg toolset. No need for any other tools, open source tools. The pattern is quite simple and it works inside Glue, but I would also consider it generic enough for any other execution environment. Yeah, so this would be it from my side. I've included some of the sources I have used. These are really good articles. Some of them really go into the trenches when it comes to Spark streaming as well. So I recommend you to check it out. Thank you very much.
Thank you, Attila. A small applause to you. Very interesting. Any questions to Attila about change data capture and Iceberg? Yes.
Does the change data capture work with does the change data capture work with upserts, with with data that is changing? So append only, I know that it works, but upserts, I think it's at least in the Iceberg Spark, it doesn't work.
I'm not sure, but I think append and upsert works, but merge doesn't. So that breaks.
Why not?
I don't know. Maybe you should tell me. Yeah, I guess the underlying files could be modified or something like that, or overwritten. But I've tried merge and it didn't work.
Okay.
So actually, there is an ongoing work to make that work, but it's still not there. So there is open PR for that and so on. So if you have time, you can search for Talet's corresponding PR and you can review.
Ah, cool.
Thank you. Everyone heard, guys, for the PR contributions are welcome. Don't hesitate. So cool.
Thank you.
Then thank you, Attila. And we have a change to Attila, who is going back in the time, I guess. Yeah. Jumping from Attila to Attila.
Yeah, it's a very common name in Hungary.
You already online? Yeah, perfect.
Share my desktop. So thank you very much to having me here. My name is Attila Turóczy. I'm right now working for Cloudera, and in this case, actually, we are going to talk about the back in time with Iceberg. So this is like a historical lesson that will be that what was the Iceberg and what was the reasoning behind the Iceberg. So one thing that I would love to also ask that who is actually touched the Iceberg now? Developers also, I would say, counting in this case. Iceberg. Okay. At least actually I will have some audience who never touched it. It is cool. So let's go actually back in time and how the database worked actually somewhere in between the 2000s. So in the couple of years ago, or maybe 20 years ago, or 25 years ago, even more, we have just OLTP databases. OLTP databases was good because you have a transactional database that was fast, that was highly normalized. And actually, let's imagine that you have a web shop and you are using the OLTP database like PostgreSQL, MySQL, Microsoft SQL Server. But of course, actually, you do not want to execute analytical workload on these databases, because if you do, the network operation team or the SRE team is coming for you, because what do you do there? For that, actually, you can have an OLAP database that is mainly for the analytical workload. In this case, in the early 2000s, you could buy for a tremendous amount of money, let's say Microsoft SQL OLAP database. That was extremely expensive database construction from the licensing perspective. Not to mention, on that case, actually, you will have a backup, for example, your OLTP database, put into the OLAP database, you denormalize it, and you are able to execute the query. But there were a problem with these databases. One is it was extremely expensive. Second, the storage was together with the execution engine. If you need more storage, you need to buy more licenses. And some of these licenses was $30,000 per year. And of course, actually, that was a problematic part because you need to have an ETL workload from here to here and still actually using, I would say, some kind of same tool set that you use in a OLTP world, but still expensive. You could have, I would say, slower query, but whatever. And also the query could be denormalized because it was mainly for analytical one. So you can create a dashboard, you create some kind of reports or not. So after that, the data lake come into the picture. Actually, this is that we are talking about the Hadoop world. When you will have a cheap, reliable storage, you were able to, from the OLTP and from the log files or from, let's say, from Twitter or from the SAP, you are able to get your information, put into the HDFS or SV or ADLS. I would say the first time it was HDFS. It could be structured, semi-structured, it could be a picture, whatever that was there. But if you are putting analytical workload, majority of the time you choose Parquet, ORC, or Avro. So it was good because the data lake was the single point of truth. It was cheap. You were able to create a cluster with your, I would say, your computer even at home. Even you go to the Media Mart, you are able to get actually computers and you are able to create a cluster. But there were a problem because if you have here the data files already that you, I would say, migrated or you have the ETL workload to here, here you still needed to move your data to a data warehouse. You maybe filter it out your data. You maybe actually just not want to put here. We just wanted to have provide for the marketing department. And from that perspective, it's still you needed another cluster, another execution engine, another ETL. And the data lakehouse is coming to the picture nowadays. Because in the data lakehouse, in that concept, you do not need to move these data because in this case, actually, that the Iceberg is provided to you is that you have the flexibility around your data files because the data files will be the same as before, just put a lot of manifest file around it. And because of that, and if you follows the rules that how Gabor is mentioned, that after that you will have a data lakehouse. So you do not need to move. It's now it started to be way more elegant than it used to be. But there is a catch. A data lakehouse is only as good as the table format is. But what is the table format itself? Gabor already talked about something about it, but I'm going back into the history when the whole thing was born. And was born actually in the Hive table. It was born closely with the Hive table. Hive table was one of the pioneer ones. Some of them like it today, some of them not. But still, this was the first implementation to formalize what the table is. And in this case, actually, the table was mainly a directory. Under the directory, there will be a subdirectory. This was the partition. Under the partition, there will be data files. So there were, on your file system, the table is represented actually by the folders and the folder structure, which was good actually at that time. And also there is a partition pruning because if you are filtering or the where condition on your selector will be matched with the partition, it only goes to this directory and directory list will come up and, oh, there is my data. But there were so many problems actually with this concept. It was good for the first implementation, but there were problems. The small updates was inefficient. There were no ACID guarantees, especially for the external tables. Directory listing, when you have get files, it starts if you have millions of files, in that directory, it started to have problems around. Table statistics also could be a problem because there were no single place who is updating my statistics. In that case, actually, the statistics is only updated by a different type of job somewhere else that is doing the statistics. So there were so many issues around. And that's why actually Apache Iceberg came into the picture. And that's why I mentioned the Data Lakehouse is as good as your table format is. And Ryan Blue and Dan Weeks was one of the first, I would say, they were the founders of this standard. And this started actually somewhere after Ryan left the Cloudera. He was a Cloudera, by the way. And in 2017, he started the work, or 2016, 17, he started to work actually on this table format. And from now, the whole Iceberg, I would say, there is so many specifications around it. It's a standard or something else. But from the implementation perspective, a table is right now, it's a canonical list of files. And because of these type of thing, it started to have ACID guarantee, fast query planning, physical layout is not as important as it used to be. You have partition evolution, time travel, whatever. And also actually from the evolution perspective, the V0 was actually just for the Netflix. The V1, when the community started to expand in, and also the Cloudera started to go into that direction. The V2 is when the row level deletes, update, and branching and tagging is come to the picture also. Nowadays, we are working on the V3 with the better statistics, faster planning, and also with the delete vectors. And there is no Iceberg presentation without these diagrams. So every single Iceberg presentation has to contain this diagram. This is a must-have. But one thing that I wanted to show here is this type of red rectangle. Why it is important? Here, the data files is the same as before. Let's say that 20 years ago is the same as right now. The whole table format that you can see here is just, I would say, files, imagine actually like a JSON file. Actually, these are Avro files, but imagine this like a JSON files. And these type of JSON files that we put near to this data files, maybe actually different directory, maybe the same directory, it can be this. These things, these are the rules, these are the files that makes the whole magic happen. So again, these are just files. And these files makes the whole part. And if you have nowadays an external table, and you would love to play actually with the Iceberg, you mainly actually just need to create these files. And even actually Apache Hive, Apache Impala, and Spark has a functionality for to migrate, which is a zero-risk migrate. So again, in the past, we have folders, we have subfolders or subdirectories, and in there we have files, right? And but the problem with here, the analyst was actually executing the query. Let's say the select star from customers where first, well, I would say country equals is Germany. In this case, actually the partition could be Germany. It's coming to here. But if the select statement or the where conditioning or the prediction is not good, and majority of the time is not good, there could be a full table scan, which is problematic. Because, and also the analytics or the BI analysts, they do not know how the physical implementation, how it is seated on the file system, right? Because they do not care. They are just creating a query and execute. And here, because you right now has metadata, in this case, actually, you do not need to go under the hood, even to the data files in some scenarios, because just another, I would say, example. In the data files, you can have statistics, minimum, maximum, whatever. Every single data file could have it. And if you have thousands of it, you need to open it, even just a footer, just to give me the statistics of it. Here, with the manifest file contains some kind of statistics around it. And it's also something it's safe for you, because in this case, the engine just opened the manifest file and there is a statistics. Okay, in this case, I do not need to go under the hood, so I save time. And in this, and also the planner, it could be so smart because the statistics are available, and it's much faster to create a statistics around. Second, in-place table evolution. I don't like this word. In the past years, when an enterprise company wanted to change a schema, it was a problem. Majority of the enterprises, there is a statistics around it, it's only changed twice a year, the schema. The startups change 30 or 50 times more than the enterprises. Why? Because with the ORC Parquet, where the schema is actually belongs to the file. In that case, actually, when you change the schema, you need to rewrite the files. And just imagine you have 5 petabytes of data, and in one transaction to rewrite the files is painful, it is hard, could be fragile in some circumstances. It is not as good. Now in present with the Iceberg, you will, again, everything is metadata. If you change something, it is changing in the metadata. Even you are able to change the name of the column from the ID, let's say customer underscore ID, and we don't have any type of problem because, again, the engine will be smart enough to change, and there will be a tracking inside internally in this case. And you do not need, well, majority of the time, you do not need to rewrite. Also, there is an option to change the type, which is one of the not something that we like, but it is possible. Of course, actually, only for the safe changes, int to long, float to double. But for example, float to byte, it couldn't be a good idea. And again, it is just happening not to rewrite the data files. It is just on the metadata file. So it is like immediately will happen. And your current workload, majority of the time, I would say 99% of the time, wouldn't break it. So if you have a dashboard, you can do this. And after that, maybe actually for the drop table could be or drop column could be a problematic part, but majority of it will be okay. Partition evolution. Partitioning is, as I mentioned before, if you have a good partition and you can able to filter it, for example, the date, that case, actually, you can have a very good partition pruning, for sure. But if you are missing, actually, the partition, or you do not provide this predicate, there will be a full table scan or some kind of problematic query. And also, in the past years, there were the file system. So this type of information is stored in 2 places. One on the file system level, and the second in the metastore level. And on the file system level, you maybe have a year, per month, per day. This is how actually a table or a folder structure look like. But also have a metastore level. And we see so many times, actually with Peter as well, that how many times we have an escalation that it started to be something that is in the metastore. It was not matched actually that we have on the file system. And this is a problem. For that, there we have a tool that's called the MCK repair, and have to go to the customer and do it. But it was terrible. It was a terrible user experience, and also for the engineering as well. Now, again, partition information stored in the manifest. Again, this is the magic word in the Iceberg word, the manifest file. These information, again, in the manifest, not in the, it is not representing on the file system level, but in the manifest level. So if you change the partition, in that case, actually, from now, if you change it, after the new, I would say, transaction, it is happening with the new spec, under the new spec. If you have an old data, you will have an old data spec, and you are able to query it. So I would say wouldn't hurt it. Of course, actually, it is a possibility to rewrite the files again. It has a possibility. but you do not need. And this is the beauty of this, that right now, everything that was in the past, it was heavy from the architecture perspective. Now it's way more lighter. It's way more elegant. It's way more, even if you put actually this type of workload in the cloud, it may be way more cloud native experience. You will feel the whole part. It is not on the file system. It is mainly actually around the manifest files and also around the rules that we have. And last but not least, the ACID transaction. This was a terrible part actually from the Hadoop itself, because the Hadoop in the early days was not designed actually for this type of workload. It was mainly for the inserting and the read, but the update and the delete operation, it was not actually designed for that. And one of the first implementation was the Hive ACID table, or the Hive managed table, that's how we called it. And it was the first implementation. There are so many argue on the Stack Overflow or on the Reddit that how the implementation was good or how the implementation was bad. But again, this was the first one. This was the pioneer actually on the market. And we can, in that case, yeah, it was heavy, it was complex, it was kind of logged in the system, because you will have a vendor log for the Hive ACID itself, and not other engine does not able to, or very limitedly able to read the data file or read the tables. And also this type of implementation was not designed actually for the cloud itself. It is possible to use, but not the best one. Also, the logs are managed in a central place in the Hive metastore, which is also, we can have a question mark that why it is there, but this was the design part. And I think actually if we go back into now, I would say 10 years later, more than 10 years later, maybe we will do it in a differently, or the Hive would do it in a differently. But again, they started, they have an idea, they put actually their idea into the implementation, and they did it. 10 years later or 15 years later, we have an Iceberg that the Iceberg do it in a way more, I would say, efficient way, or way more elegant way, because this snapshot isolation, this is more engine agnostic. Right now, every single engine, even it is Hive, even it is Impala, even it is Fin or Spark, whatever, they have the same knowledge about the transaction. In the past, actually, the Hive knows majority of the transaction, others not. It was very logged in that case. So again, the messaging around this Iceberg part, it is everything actually with this type of table format started to be way more lightweight, way more elegant. It is easy to use. And that's why majority of the company started to think that how we will able to invest in this table format. I think that's why actually also the Cloudera is always investing into the Iceberg. Microsoft is investing, others too, and other companies also. And this is why actually it became, I would say, very favorable. Before I stop, I also wanted to have, just give me a marketing part. We here at the Cloudera are working on the Iceberg. Majority of the people who are working actually in a data warehousing group are belong to them, even on the Impala, even on the Hive, or maybe on the Trino as well. We are working on it. And every single year we hire new and new people to the Cloudera. We also have some kind of perks. We have Unplug Days, which is also happen on this Friday. So it is, in this case, we do not need to work. If there is no escalation. And also we are working on the open source technology. If you are interested about this technology, or you are interested about the Cloudera, please go to the career portal. We have right now many, many open positions. And Gabor, if you're bored with the Microsoft, you can always come back to us. So thank you very much. And I hope you will have something that you find interesting. Thank you.
Thank you, Attila. It was nice. It was very interesting. Cool. Then, guys, any questions about the historical overview? Any IT archaeologist here in the room? Yes?
Actually, I have a question regarding Iceberg. I have experience of working with delta tables before, and everything what you say about Iceberg seems to be the same with delta tables. So what is the advantages of Iceberg over delta tables.
Oh, compared to that. So the question is compared to that the data table, right? So there is actually there are similarities, to be honest. But one thing that is how I would express this one. When you go to the data tables, it is actually, is it open source? Yes. But the open source in that case, actually, the majority of the developers are coming from the Databricks. There is, I would say, one Microsoft engineer, maybe one Uber engineer in that community. There are maybe a couple others, but it is not truly open source. It is on that case, yeah, you are able to check the code, that how it is working. But the beauty of the Iceberg is actually about the whole community part, because there are so many people are arguing, so many people is actually adding part, and this is what I see, what I feel this is a true open source part. But yeah, from the functionality perspective, there are similarities. But in my mind, even on the functionality part, I don't remember if the data tables has a branching and tagging of this. I don't think so. Right nowadays, what the Iceberg provides is way more advanced. Not to mention a huge amount of community behind it. And I would say if the community is always, if the community has a heartbeat, it makes actually this product is way more interesting for the whole world. And also, not to mention, recently the Databricks is acquired
Tabular,
yeah. So actually, they also have some kind of thing. I guess actually they also moved to the Iceberg world as well.
Last year, July. It's not recently anymore. But like to answer your question, maybe always leads to Rome. There's a saying. But the Iceberg one is the best, most crowded. Not just on the Databricks, is going to be on the road. Cool. Any other questions? Any job applications? Yeah. No, not today. Okay.
Immediately we could have a interview because the talent acquisition.
It's all served, guys. Here. It's very agile company. Well, thank you very much, Attila. Thank you again for your talk. And right now, guys, we have 30 minutes or 20 minutes time for a networking session. So right now, use your time, grab a drink. There's some snacks still there. Have a conversation, ask your question. And see you at 7:30 again. Don't run the recording. There are 13 people online. So we just about to start the last two talks about Apache Iceberg. And it's going to be more about the future and not about the past. Peter is going to show us about the new file formats that's going to be very, very soon available in Apache Iceberg, right? All right, so take your seats. One moment.
Can you hear me?
Can you hear me? Yes. Yeah, just close or take this one.
Okay. Thank you, everyone. I'm Peter Vary, and I have been working with many of you in Cloudera for good 6 years here. And after that, here I have started to work on Hive, and after that, Hive Iceberg integration. And this is where my Iceberg path started. And then I moved to Apple, and there I was working with Flink Iceberg integration. Again, Iceberg got me there, and I have learned how to make it work with Flink. Created some interesting projects there, like dynamic sync for writing multiple Iceberg tables with a single Flink sync, and also making table maintenance available for Iceberg sync. And beginning of this year, I moved to Microsoft, where I started to work fully on Iceberg, fully on the core Iceberg, and making sure that we have a more open community and with many new features. As you probably know, I'm an Hive PMC member, and also I'm Iceberg PMC member. And what I would like to talk about is the file format API. This is the thing which I'm working now since the beginning of the year. I would like to create a new interface which allows users to read and write Iceberg data files and delete files, and do it without knowing any dirty details about the file format, any details about how they are stored in a performant and generic way. The work is what I'm doing now is Java. I'm doing the Java implementation, but I'm hoping that the other implementations will follow. What do you know about the current file formats? Currently, there are 3 file formats available in Iceberg. The row-based file format of row, which is easy to read, easy to write. This was the first one. This is how the metadata is stored at this point. And the columnar file formats, Parquet and ORC, which is really good for full table scan, filter, push down, and so on. There are many new file formats coming up. There are new things coming up around the file format ecosystem, new encodings, indexes inside the files, new flexible layouts, not just row groups and then columns, but many new things. GPU optimization, direct loading for GPUs. It is really, really important to start using those possibilities. As Attila told, Parquet is the same file that you have written 20 years ago, almost 20 years ago. There are these new things which are get out from the academic world, are ready to use. So we would like to see them in Iceberg. A few things, I mentioned Lens, who basically has raw data and writes directly to the files. It has external indexes. It has very good vector handling. Vortex, another file format which is coming up. It has a very, very flexible layout. You can create something like Parquet under Vortex, but you can create a much more performant layout for that if you're looking for random access. You can have very good indexes inside the file format. You can very good response time if you are looking for a single record in a big file. It is also open for new encodings. It has a very vibrant community. It's very open for new ideas. So these are just examples. There are plenty of others you can choose, but these are the prime examples. And why I'm very excited about this, just look at these results. This is when you are looking for a single row in Parquet, and this is when you are looking for a single row in Vortex. I think this speaks for itself. So what we have currently in Iceberg, we have our own read builders for all of the file types. We have the exact same code or very similar code duplicated for ORC, for Parquet, for everything. So everybody creates our own read builders. Everybody creates their own write builders. And when you start to use it, you have to create your big, big, ugly case statement. This is just the smallest one. So this will, it hurts your eyes when you are looking at that, and okay, don't ask me. Okay, and this code application basically creates a hotbed for missing features. There are some features which are implemented in ORC. There are some features implemented in Parquet, and nobody really knows what is missing, what is there, what could be used, but is not able. You cannot be used, and it's full of unknown unknowns. You don't know what you don't know. So what we have been thinking about, how to make this happen in a generic way, how to really read the data from a file and arrive to the engine. Every engine has its own data format in memory format. Every file format has its own data format on a disk, and you need a conversion between the two. You read the data from the file, convert it somehow to the engine format. You can do it in two ways. Either you can create a common file format, read from the file, convert it to the common file format, from the common format,
converted to the engine format. This is on the hot path. This is happening for every record. This is happening every record when you are writing. This is happening for every record when you are reading. The common path is very good if you have multiple file formats, multiple engines, and you don't want to write the encoders, decoders every time. But if you want a performant one, you need the direct conversion. You need the direct conversion. So we went with a model which allows to the direct conversion. Later we can introduce an intermediate one, and we can say that, okay, this is an intermediate reader is there, and from the intermediate you can read it from the engine. But we need to provide the possibility to have a direct conversion. So this was one of the big decisions which we needed in Python. Also, here is the information which we are collecting during the read and write. We have information from the user. This is the file which we are reading. This is the split which we are, this is the part of the file which we are reading. This is the projection which we are in. These are the columns which is needed from the file. This is the filter we need to apply to the file. This is coming from the user. But there are other part of informations which are needed for the reading and writing coming from the file format. This is the file schema. This is the binary format inside the file. This is only known for the file format. And the third source of the information is the engine, the input schema, which we are getting for the writers, and an output schema, which we are writing, providing for the readers. So we have three different sources of information, and we have to combine those. And it was very, very hard because the reader and the writer needs to collect all of those informations to provide information to provide the readers and the writers. So we separated out the information coming for the user to the read builders and the write builders. In the read builder, you can get the file, the speed, the projection, and the encryption. On the write builder, you get the schema, the concept type, the config. So these are the main interfaces which the user will interact with. They will have a read builder, they will have a write builder. And then come the format model. We call it a format model when the file format and the object model are connected. So basically it says that we are converting from this file format to this object model. This is the format model. And these are the types created by the file format itself. And the input for that which is the file format, and it will create the write builder and the read builder, but provide a way for the engine to configure the readers and the writers. This the configuration, you can think about it like the previous reader function, writer function, and so on. This is how you can set it in the format model. And then the engines could create the format model instances, and it could provide the functions for the format model, which is finally creates the full reader and writer generating format model. And we put everything which I have been talking here into a format model registry. This is the central component. In this format model registry, you can register your format model, and users could access this registry. And with providing that this is the file format which I'm reading, this is the input type, this is the output type of the class which I would like to get, and this is the input file which I'm reading. Please provide me the reader. Or if you are writing, then you can go to the format registry. I would like to have a data writer. I would like an equality delete writer, or I would like to have a positional delete writer. And again, providing the file format, providing the type of the class which I providing as an input, and an input file, output file, sorry. Then it will provide you the writer. This is how it looks like again. So we have the registry. We register the generic format model, and the Spark could register the Spark format model, Flink could register Flink format model, and every other engine could register its own format model into the registry. And then when we need to create the write builder and the read builder, these models are creating them. So this is every format model will create the read builder and the write builder. And in the case of write builder, it is just for the binary writing. But we have the data builder, positional read builder, equality read builder interfaces which are providing the actual files, data files, positional read files, equality read files, which could be added to an Iceberg table. And the registry actually creates those, and this one. These are internal for the whole stuff. So what you are doing, you are just going to the registry, request a reader or request a writer for your file format, and you can do that. What we are also planning to do after it gets in, we would like to create a technology compatibility kit. TCK basically would like to create a way to validate new file format. So we created a unit test set. With this unit test set, you can basically run against your own file format model, and you can validate that, okay, I'm doing everything which is specified in an Iceberg specification, so I can fully read and write an Iceberg data file. And if this Java format model is provided for any Java implementation, engine implementation, it's implemented by them, then we can make sure that all of the features are implemented. Or we can say that V2, V3, or other level of compatibility is there. So it will go through all of the features, all of the data types. So it could allow us to ensure the new file format is feature complete, or everything is there. And with this in, we have plenty of really cool stuff which you can achieve. I have already showed them the Vortex and run stuff. We can have files, we can have tables stored in Vortex where the user reads random access, only a single rows. We can allow that for them. They just could say that, okay, store this table in once. We can, I have been playing around creating column families. It is like splitting a table, not just horizontally, on vertically too. So you can have few columns in the first split, second split, whatever. In this case, if you want to switch out a single column, want to update a single column, a few columns for a very wide table, you don't have to rewrite the whole table there. You just rewrite a single column and say, okay, this is the new file which you need to read for that column. And then you can create a reader using these interfaces, which will read and collect the row from the multiple readers. Also, you can play around with the writers. You can split it out and use multiple CPUs to encode the data. I have played around with that, and with the cost of CPUs, you can have very good writing performance, for example. With the cost of I/O, you can have very good I/O performance, because then you can combine the data. Also, another thing which it could be used for is in indices. If you have the Vortex table, you store a materialized view above the table, creates a which is stored in Vortex. Then you can split out reading the table instead of reading the Vortex table, and you can have a very good response type for reading specific rows. And yeah, and also this could happen in faster retrievers. I have collected the information here. Here is the proposal, the PRs. There is an API is there. And the proof of concept PR is there also, which shows how we can switch out the whole implementation in Iceberg for these. And here is the column families proposal draft as well. That's from my side. If you have questions, I'm happy to answer those.
Thank you very much, Peter. It was interesting, and it's. Can you hear me, guys? Yeah. It was super interesting to see like the future of Iceberg, and now you have a chance to ask a question an Iceberg PMC. Use that chance. Any questions to Peter? Yes.
Hi, thanks for the presentation. I'm interested about, is there any kind of product releases or
Sorry, I don't understand you. Can you louder, please, or not?
Yeah, is there any kind of product on the market using this technology, Iceberg?
Currently, it's not yet in open source, so it is no open source usage of that.
Okay. I mean, for instance, is there any vendor or some software company?
Not yet. Not yet.
Your question is about is vendor for Iceberg? Oh, yeah. So, well, it's probably easier to say who is not using it, to be honestly. So, like Microsoft, Amazon, Google, Cloudera, Starburst, LinkedIn, Alibaba.
Oh, sorry, you were asking.
Yeah. So the question
he was asking for Iceberg usage and not for this feature usage.
No, for Iceberg in general.
Oh, I see. Okay.
That's so that's like the main thing what is used by like almost everyone in analytical space. Yeah. So if you want to do the data analytics, then Iceberg is the way to go. Yeah. Spark, for instance, uses Iceberg massively. Yeah. Cool. Any other questions? Yes, we have a question.
Could you please tell us a little bit more about this huge difference in performance between Parquet and that file format that you mentioned in your presentation?
Okay, so basically the main big difference between Vortex and Parquet that Vortex has a very good indexing system internal in the file. So when you are writing out a Vortex file, it makes sure that you can reach any record in all the one time. I mean, in Parquet, you usually have to go through the row groups and then filter out the row groups based on the statistics around that, and then the Iceberg Parquet reader basically goes through the last row group one by one until it finds the required record. So even if you have a single file, even if it is sorted, even if it is there is a single record in that file, in Parquet, in the Parquet Java reader goes through the last row group one by one and then returns the value there. Okay, so this one is in the open source in an open PR. It is not accepted yet. We're still reviewing it with Ryan. And when it gets there, it will be there. But the next step will be to create the reader and writer for Vortex. We did it internally, but it is the next step we need to do. So the Vortex will be available after that.
But feel free to contribute and to get it faster, I guess. Any other questions or looks? We don't have a question.
Do your changes have any impact also on the metadata? Do you, or is only on the reference data files?
So the file format stuff is just code change. It doesn't do anything externally, not even the APIs and anything else. The column families, the index is a different story. There will need metadata change.
Perfect. Then, Peter, I would say thank you again. Thank you very much for your presentation. I'm already inside. So it's now on me. Good. So, guys, you're almost done it. The last talk. I hope not to make that too hard. Unable to join this meeting. Okay. And let me just try the number. Where's the guy? What's the number? Oh, join. Yep. Here we go. Yeah. Sure. Oops. All right. Cool, guys. So I will try to give you like exactly to answer your question about like a Lakehouse Iceberg, about the REST catalog. We heard from Gabor about like what the REST catalog is actually is and what is actually the future of a REST catalog. So is it a catalog at all, or is it something more than the catalog? Well, beginning, I want to do with open source because like the whole thing why we today here in that room is because of open source. So like everything what you just heard and got presented is because we have Apache Iceberg. It's a huge community. It's, and the beginning was Hive, Metastore, Hive, what Attila was presenting. So therefore, like a very, very quick question to you. Who is using open source on your daily job? Can you raise your hand? Oh, that's the usual situation. Now the tricky one, who of you does contribute to open source? That's a different picture, right? So that's what I want to do here as a motivational speech for open source. It is actually the innovation driver, and use it not just because you develop something and someone is going to use it, but develop because it will help to develop yourself. So invest your time in open source, go to all that communities, pick Iceberg, pick the other communities. There are a lot of different communities that you can actually contribute to and help to develop open source. Very quick introduction. My name is Victor. I'm one of the co-founders of a company named Vacamo, and Vacamo is a company who developed a project Lakekeeper, which is licensed under 2.0, Apache 2.0 license. It's open source. Here's again, if you want, you can actually go and pick an issue and contribute. We are written in Rust. So everyone who would love type safe languages, you're welcome just to go and then write something in Rust. And I will present you exactly what we actually implemented, how we actually see the REST catalog, how the evolution of the REST catalog is going to be. A quick slide about the Iceberg. So, you know, like in the 90s, we started with data warehouse, we had Oracle, Exadata, we had Postgres, still we have Postgres. And it was fine to have that for the structured data. So you have your SAP, you could extract data from SAP, load it there. All is nice. But 2000, internet happened. And everyone like, okay, so we have semi-structured, unstructured data, what to do with that? And then we have a rise of Hadoop, Spark, Hive, all that systems. And then that helped us actually to store a lot of that data. 2010, cloud happened, and people started to ask questions like how to actually go with that cloud thing. And we have new stars here like Snowflake and Redshift. And what those companies could actually create is to not just easiness and frictionless of use, because you click of a button and you have the whole cluster, but they actually could separate storage and compute. It was not tight anymore, so you can actually store as much as you want, and then you can provision and compute as much as you need. So guys on the big data, we said like, okay, we can do similar. And Databricks was probably the main player here who can provision you like software as a service for the data lake, and then you can store the whole stuff. But as Attila described, those systems on one hand, too expensive, on other hand, didn't provide all features what we know from a data warehouse. It's how we came to the idea to create something like a lakehouse. And today, it is actually the leading paradigm on the way how to analyze the data. So if you want to build something and you want to build the analytical system, you will probably start building something on Iceberg. And it's not the question about the size of your warehouse. It's about like how you want to treat your data, how you want to evolve with your data, and everything what Peter just presented in the future on AI use cases is going to be covered by Iceberg. And all that tools that you can use can be really, really easy plugged to that system. But what's the Lakehouse? A very simplified kind of like slide about the Lakehouse. There are only 3 components what you need. And it's storage. It can be like S3, any object storage. Compute, Spark, Python, Databricks, Snowflake, Trino, Starburst, you name it. And a catalog that is taking care of everything about the lifecycle management, about the access. So those are 3 components. And if you will look at those components, you will probably find, if you will put that all together, a Postgres database. So what has actually happened from 1990s till today, someone was just decomposing the monolith to all that 3 components. So what is actually Iceberg? So we got 4 talks about Iceberg. What is Iceberg? Well, Iceberg is just a bunch of specifications. There's a table spec, view spec, path and spec, REST catalog spec. So communities got together and said like, oh, that's how it looks in the future. So that's how we actually see the world of Iceberg and how Iceberg is going to be built. So everyone can participate on that one. So since my company is most time involved in a REST catalog, I will just go to the REST catalog and explain you the future of it. So what is the evolution of a REST catalog? Well, as Attila told us, that's the main picture, right? So we need to show that picture. It's Iceberg. And I see that in 2 phases. So we had the before REST era, and we had all of that different catalogs out there. Hive, Hadoop, JDBC, Nessie. And it was quite fun because it was a huge innovation push, I would say. The challenge was, on the other end, for every client, for every Spark, for every Python, for every Trino, to implement this catalog, because they all have spoken like different languages. You know, like right now we speak like English, everyone understands. But in that case, it was like everyone was speaking different language. It was super hard to drive the adoption. Luckily for us, we've got the after REST. So we've got the REST specification, and as you can see, the difference between before REST and after REST is that REST is in charge of metadata JSON file. And that's kind of like a game changing, because right now there is a single entity that is in charge of all that transaction, what is happening on that Iceberg, and not just like before. Catalog is only to point to a metadata JSON file, so you know like what is the current state. So if that changed, we've got actually our catalog. Easy to implement because every compute engine knows now, okay, there's a REST specification, I will implement that REST specification, and I'm good to go. Consistent multi-table transactions, but very confusing. If you go to companies and they will tell you need a catalog, and I have Data Hub, I have Colibra, I have Alation, or Atlas, and like, no, that's a different type of a catalog. It's a technical catalog that you need to write Iceberg, a very long explanation, right? So luckily for us, catalogs got more responsibilities. Oh, how to deal with authentication, how to deal with authorization, access governance, monitoring, logging, audit. And companies and users start to talk about the Metastore, and it was kind of a good match. We had a Hive Metastore, then Hive disappeared, and Metastore remained, and now we have like a Metastore. But looking forward and looking with what we can actually do with that metadata JSON file and the control of that file is that we don't speak about the Metastore anymore. We speak actually about the control plane. When I talk to customers and to companies, they tell me like, okay, that's the part which is actually essential, because if that part doesn't work, no one can read and write. Or even more interesting situation, everyone can read and write. And that's like companies very, very crazy about that situation. So we have one component, infrastructure component, that is in control of what is happening on my lakehouse. So we've got the control plane. That control plane is actually allows you to connect to all the different storages. It can be on cloud, it can be on-prem. It doesn't really matter. And that is actually how revolutionary Iceberg is, because you are not tied anymore to any storage. And same on a query engine. You can say like, oh, I want to use Spark, I want to use DuckDB, I want to use Drino. You're not tied anymore to a compute engine as before. You know, like the time before, oh, I have my Teradata, and now I want to go to Snowflake. What is going to happen? You will have 2 years migration project. That is probably not going to be finalized. You will still have a couple of Teradata licenses somewhere because some use cases was not able to be migrated, and you will just collect all your technical debts. The Iceberg is actually the final format where you need to migrate. You'll migrate to Iceberg, and then use case by use case, you can make a decision which query engine you're going to use for that. And it's quite comparable when you build a house. Here we built a lake house, but imagine you built a real house. You don't need to think about, do I have a hammer that can build everything? Or sometimes I need a screw, sometimes I need a drill, a saw, all different tools. Similar here. The only one thing is what is not distributable at the moment, at least, is the governance, is the table management, the maintenance of your table. So you need somehow to control that. Who is accessing your table? So right now, imagine you have your table customer, which is on Amazon S3, and then you want to read that table, and then you will say, okay, I have 5 different query engines where I should put my governance. Where should I put like that user A is allowed to read that table? Should I go to every query engine and put that information, or should I somehow centralize that? And every query engine needs just to follow the policy. And that is actually the easiest way in that case. And the funny part is if you will go from data to AI use cases, you will understand that, oh, you need even to apply that for AI use cases. It's why what Peter was presenting about the file format, and if we want to have some AI use cases, that's how the control plane can actually help you not to give access to your data for everyone. So what is actually the future of Iceberg REST? And I want to talk about security and talk about the events endpoints. So how the fine-grained access control actually works on Iceberg? Well, we have our storage, we have our catalog. What we made at Lakekeeper, and that's something what you can use as well, we didn't put the authorization inside of a catalog. So the decision was made to make that outside, but very close. So there is a trait, and that is authorized trait. And you can actually go and implement it by yourself. At the moment, what we took is another open source project, OpenFGA. If you're not familiar, you can Google Zanzibar paper, and it's a new way of relational-based access control. So it's a superset of ABAC, AirBAC, different bugs. And you can use it. It's quite interesting implementation. But if you want, you can actually replace that with your own stuff. What do we do in our situation? Well, because we here in Europe and especially in Germany, we kind of like trying to control the stuff. We want to run that on Kubernetes. And that is easily doable with our situation because Lakekeeper is Rust, single binary. You can just deploy with a Helm chart, super easy. But the thing is, what we made as a decision as well, Lakekeeper is not an IDP. It's not an identity provider because it should be only single identity provider inside of your company. It's either Entra ID, Okta, Keycloak, I don't care, but there is one. So we, as a Lakekeeper, we're not going to issue you any PATs, access token, and so on. So we will connect to your IDP. And then what we have, an Iceberg topic, we have 2 different types of computes. There is a compute, a general one, which you're going to use on a daily basis for your batch job, so that's going to run and write data. And in that situation, you will have usually a single technical user, which is fine. You will just create that user inside of your IDP, and that user can just go and write the data to your customer table. But then we have a funny multi-user system like Trino, for instance. And in that case, you have, well, 10, hundreds, 1,000 different users. And then you need somehow to tell that user Peter can read table customer and user Anna should not read the table customer. So how to do that? Because Trino will create a catalog connection with a technical user. And that is not possible here just to say like, okay, I'm not actually able to enforce that somehow. Well, we have another open source technology, the Open Policy Agent. And there is a bridge was developed by Bloomberg that allows you to enforce that policies that you're gonna store inside of your authorization system. Like in our case, it's OpenFJ. In your case, it might be something different. You have your policy. Well, usually it's a simple tuple where you have a user or role, an object, customer table, and the action can read. And what is happening here in that case is that Trino asking of an Open Policy Agent, I have a user Peter, what is allowed for user Peter? Or user can read the table. Okay, we will allow them. But then we have user Anna, then Trino will be using that path, that bridge, and actually enforce your policy. And in that situation, you can build the Lakehouse. And by the way, he is like absolutely open source, not just open Lakehouse, but open source implementation of a Lakehouse with enterprise-ready security. So you can actually implement that and play around. But when I have a conversation with all that companies, they say like, oh, so many moving parts. That's very hard. So why not just to get rid of something? And yes, we have a FCAC proposal, guys, at Iceberg. You're all welcome to contribute, to talk, to discuss. And with that FCAC proposal, we will actually exactly implement this type of a system that the communication between catalog and the query engine can be enforced, and the information can flow and help you to secure your data access. Always read something in the small. Limitations. There are limitations. That is going to work only for the trusted compute engine. So if you still want to read with your PyIceberg, it's not going to help you because PyIceberg can just go down, read the whole Parquet file, and understand what's inside of your data. So be careful. That's not a solution for everything, but still, it's a good progress. And that proposal does not have any FCAC, any policy management, which means we going towards like, okay, now I'm kind of can deal with identities, but what about the policies? We heard something about lake formation, not the best way. Polaris has own policies. We're trying to play around with open source policies, so there is no standard yet. There is another proposal that actually exactly trying to solve this problem so we can get the permissions policies, and that policies are going to be stored like in REST catalog, and the query engine can use that. And in this situation, we'll actually get to a state where policies are standard as well. So which means if we have identity as a standard, policies as a standard, the security can become a standard. I just recently had a talk with a big company, and they told me, it's nice to have a standard file format or table format, but the governance is actually in a very bad shape because we don't have those standards. And actually we, as a whole community, as a data-driven industry, we will absolutely benefit of that if we will get open governance standards. We will see. The next topic is endpoints, and was quite interesting to see on change data capture and what Attila was presenting. But my co-founder Christian was proposing that, and it was discussed, and I think it's agreed, and it's going to be part of a REST spec. There is a new endpoint events, and it's quite interesting what you can do. So imagine the situation, you have Trino. Trino is updating the table, talking to REST catalog, and the REST catalog, yeah, at the end, right, the metadata JSON file, which is hopefully going to be obsolete, and we don't need to write that in the future. So make the things a little bit easier. But in that proposal is that we will have an event store that will store every metadata information you actually run on top of your Iceberg table. And the cool part with something like Airflow, you can go and say, I want to actually get the events on specific table, put the filter on that query,
and you will get create table, so which you can then use for maybe CDC. Maybe you can build some third type of application, like, I don't know, fraud risk detection. So it's quite interesting what you can actually do with that type of thing, because Iceberg is less about the data in the first place. Iceberg is about the metadata. And what we trying to achieve that your metadata is going to be actionable, because everyone is complaining about, or I don't know, like the quality of my data, or the ownership of my data. Like there's a table belongs to John. I want to make a change. I go to John. Well, John left the company for 2 years, and we don't have like that kind of like connection here. But that's exactly what we can achieve through the actionable metadata, and that's the new stuff inside of Iceberg, is the event store, which is going to be part of a REST catalog, and you can actually use it. So how you can use it? Yeah, workflows, triggers, notification. So as I said, you can think about that. You make a new change on your table. So you inserted your data, and what you have bronze, silver, and gold layers. So now you have a new data, and then you can make a decision, or do I need to go now and load the data from a bronze to a silver to a gold? So you can make that everything actionable and triggerable on top of your system. The next thing is quite interesting, is federation. So today, when we talk, oh yes, we have this catalog, and then you can imagine big corporations where they, at the same time at Microsoft and at AWS Cloud, they have Glue catalog, they have Microsoft catalog, REST catalog, there is Snowflake REST catalog, and there is a crazy guy from CISO who doesn't really know what to do, because so many catalogs and every catalog claims to make the governance. So the idea is here from a business story, okay, I can do the data mesh thing. We talk about the data mesh today. I can tell like, okay, HR, you on a Snowflake, keep it. And marketing, you use Glue catalog, keep it as well. But me as a CISO, and I want to drive that for the whole company, I will install a one federated catalog and just pull the whole data through that mechanism endpoint in a single catalog, and will manage from that single catalog that every company employee can go and use the data. So that's quite interesting, because the picture what I showed to you for, I don't know, a couple of slides, where I had multiple storages and I had multiple query engines, you will end up with multiple catalogs as well. But then probably you need to make a decision which one is going to be the control plane to rule them all, and to provide you a security and governance. Yeah, same on audit and debugging. Yeah, so you need to have audit, because you can capture every change on your table. So you run a DDL statement, you can capture that. You run the DML statement, you can capture that as well. So you have all that information. You want to debug. We heard nice stories here about the experience with Iceberg. So that's probably the way how you can do that as well. So quite interesting. Going to be very soon in production. So I'm expecting to have that next year probably, and that is going to be like the part of a spec as well. So almost running out of time. Takeaways. So from my understanding, it's not a catalog anymore. It's a control plane, because that's the entity that controls everything on top of your lakehouse. If you want to read, if you want to change, you want to give access, you want to create vended credentials, etc. pp. So doesn't really matter. If you need something from your warehouse, you will run to a catalog. What's the location of my table, or can I read that table, etc. And I think if we will add more file formats, and we will add not just analytical use cases, but AI use cases, that part is going to be even more critical. We see a lot of new stuff, and the one is events and federations. So I think through event endpoints, we can do quite interesting use cases in the future from a governance perspective. So we can actually automate the whole governance. Recently, I had a conversation about like how to make the governance AI driven, because if you're in a large organization with hundreds, thousands of employees, and you need to go create for every employee a role, somehow to revoke and grant roles in employees. So super complex topic, but maybe exactly for that mechanism we can achieve that. Yeah, and role filtering and column masking. Well, something what we know from Postgres, right? So I can do that easily. Or if I use Trino, I can go in and deploy my role filtering and masking. Well, on Iceberg, kind of tricky, because if you can read the Parquet file, you can read the Parquet file. You can read everything. And here's the thing is about, I haven't presented that. There is a new proposals about UDFs. And UDF is exactly what you can actually use. You can put inside of UDF your condition, where, and then country equals Hungary, Germany, whatever. And that UDF will be applied, but again, by trusted compute. So that's not going to be like helpful if you use PyIceberg or DuckDB. But if you use something like Trino or, I don't know, ClickHouse, Starox, that is something what can be very useful, because then you can apply all that different role filtering and column masking. That's it from my side, guys. About the future of REST catalogs or control planes, or maybe you have a different word. I'm keen to hear that from you as well. But maybe you have any questions. Thank you. Okay, I'm in a double role, running and answering.
I do have a question, and actually you mentioned about you are supporting the Entra, Okta, and
yes.
Other providers as well. So in this case, actually, when you are installing this service, you have to create an application in the Entra and providing to the secrets and the rules to enter to your Entra directory.
Well, you will create the application set, right? And that application had client ID, client secret, and we will use it. And through that mechanism, OAuth and OIDC, we can then authenticate you as a user.
And what kind of rules actually you need to get this information? You are reading the directory, or you have
from that one. Gotta check the documentation exactly. But you don't need to read the whole directory. So if you go to that graph, it's not directory read all. So you don't need that.
And from the application perspective, you always go actually to the Entra with every single request, or you have some kind of
caching? Yeah. Yes, we're building on a caching as well. But I think depending on what, so the token is going to be checked every time. So you don't wanna be in a situation that your token has expired, but we cache that token, or you revoke that token.
Yeah.
So we will definitely verify the token all the time.
Okay. Thank you very much.
Perfect. Cool. Any other questions? Yeah. Here we go.
When you mentioned eventing, the question that popped up in my mind is, what's your plan for handling indirect recursion between the event source user code and calling back to the actual engine that originally sourced the event?
I didn't get the question. So I have my table. So, let's go through. So I do the insert on the table.
Yep. That generates an event.
That generates, first of all, the new snapshot as a metadata change.
Okay. I think I need to I need to make one step back.
Yeah.
Is that eventing synchronous or asynchronous?
Well, it is a pull, a mechanism. You as a client will go and pull the events from event store. And we don't push anywhere.
I see.
So it's a pull. What we can do, and listen, Lakekeeper, we can, there is a mechanism that we can push it in your Kafka topic or Nuts queue, and you can build whatever you have on top of your messaging systems. But the proposal, what was made, is a pull mechanism. Therefore, event is going to be created in catalog, in our REST backend, in Postgres, for instance, in our case. And then your Airflow or your, I don't know, like different type of application, you will just go and pull it, and you will get the event.
So the event is basically queued in an asynchronous way.
Well, it is queued inside of our Postgres database, and then there is an endpoint, and you can just go and pull it and give it like every event. Yeah.
Okay. Thank you.
Perfect. Thank you. Yep.
Hi. So you have mentioned that a Microsoft-sized company can take advantage of this. Those companies are really interested in performance and HA. Are there any numbers or sayings about these things?
Yeah, well, every company can take advantage on this. It's not just about the Microsoft. If you're talking about the numbers, there are some impressive numbers from Netflix. Last year, October, at Meetup, Netflix was presenting that warehouse of Netflix has exceeded 1 exabyte of data. Netflix writes every day 10 petabytes.
I'm not asking the size of the data. I'm working at Apple. I'm asking about.
So you know the size of the data. Maybe we should ask you.
Yeah, I'm asking about this product. How HA is it, and how performant is it?
Oh, Lakekeeper.
Yeah.
Yeah. Well, it is written in Rust, single binary. You can easily scale it. The only one limitation, or like the possible bottleneck, is your Postgres, because that's the backend what we use to store the data. But Postgres on reading can scale very, very large. If you want to run a test and let me know if you saw some bottlenecks.
So does it mean that single Postgres, single, let's say, REST API is the actual model?
Well, we have a Postgres database, and then you have Lakekeeper. Let's assume you're on a Kubernetes. And then on a Helm chart, you can say replica set 300, whatever, like ports of Lakekeeper is going to be deployed.
Thanks.
And there are different benchmarks that can run, but the memory footprint is 50 MB, so it's very small.
Yeah, I know Postgres is pretty.
No, not about the Postgres, about Lakekeeper, because it's written in Rust. It's very small. Yeah. So Postgres is a different story. Yes.
Thanks.
Perfect. All right. I think we've got so far all questions. Yeah, one more. Yes.
So do you plan to support on-prem file systems like HDFS? You mentioned stores, but I know that HDFS is not supported. I also know that your colleague, Christian Thiel, created a custom image that we are actually using in our testing, but would be nice to have it in the main line. Do you have any plans about it?
Okay, so the question was, do we support, or do we have a plan to support HDFS and not object storage? We created, as you said, something, but so far there are like 2 limitations. The first limitation is HDFS does not have vended credentials mechanism. That makes actually this life simpler, because we can go HDFS with Kerberos, but then you as a client need to take care about the authentication, because we are not able to issue something like through STS mechanism. That is a huge limitation. But if you're okay to deal with that, okay, let's solve it. The second thing is, no one really wants it. We had a couple of conversations, we tried it out, we created, but no one is really asking us on our Discord. I don't see like anyone is asking for HDFS. You have a second one. We had first one, we created for them, and nothing happened. I don't know like what is your use case, but if someone needs that, reach out. We can have a conversation about this. Yes. Good. Thank you, guys.